Newton's third law states that when an object exerts a force on another object, the same object exerts on the first a force of the same magnitude but in the opposite direction. So this law is called the law of action and reaction. So when we're pushing a table, just like this shown in the picture, when we push against a heavy table and it does not move, evidently the table is pushing back just as hard as we are pushing against it. So if your force is exerted this way to the left, so this is the force exerted by the person on the table, then the table exerts a force on this direction. So opposite of the direction of the force that you are exerting. If we push a chair of the same weight as the table on the ice, it will now move away from us. How come? So we'll be able to answer that later on. And we will find ourselves moving backward away from the chair. So you exert a force towards the chair or on the chair in this direction, and the chair will also exert a force towards you. So with that statement for Newton's third law of motion, it can be given in this equation. So if the objects are A and B, so the force exerted by object A to B has the same magnitude as the force exerted by B to A, but one is negative of the other because it is directed in the opposite direction. So the third law of motion always applies to two different forces on two different bodies. So there are two forces. The first is the action force that one body exerts on another, the equal but opposite reaction force that the second exerts on the first. So just like when we're standing, or if we simply put any object on a flat surface, there is, the third law of motion is working. So if we have this book on the table, placed on the table, then the weight of the book is the force directed towards the table, and the reaction force is directed upward. So that's the force exerted by the table on the book. So for example, we want to solve this problem. We have a 1 kilogram block A, and we have another block B, which has a mass of, this is 3 kilograms. And they are in contact on a frictionless horizontal surface. So there are two questions that we need to answer. First, if a horizontal force of 10 newtons is applied to block A, find the force this block exerts on B. And if the same force is now applied to B, find the force block A exerts on B. Or rather, B exerts on A. So first, when solving problems like this, we need to draw, of course, the figure. They're called the free body diagram. So let's draw the surface. Let's say that this is the surface, and we have block A here, which is smaller. Yeah, block A is 1 kilogram. That's the mass of A. And we have a bigger block, block B. And the mass of block B is 3 kilograms. So in the first case, there is a force exerted on A. Okay, actually they're sticking together, but the force is just here in A, near A, and that force is 10 newtons. So we're asked to find the force exerted by A on B. So because the two objects are in contact, this means that both of these masses, both of these blocks, will have the same acceleration. So first we need to solve for their acceleration. Okay, solve A. So remember that force is equal to mass times acceleration. So acceleration is equal to force divided by the mass. So we know the force, 10 newtons, but what mass are we talking about? So since this force is exerted towards two sticking objects in contact objects, then the mass that we are talking about would be the mass of these two. That's 1 kilogram plus 3 kilograms, or that is equal to 10 newtons over 4 kilograms, which means that the acceleration is 2.5 meters per second squared directed towards the right. So the force exerted by A to B would therefore be the mass of B times its acceleration. That's what causes object B to move. Okay, so the mass of B is 3 kilograms and its acceleration is 2.5 meters per second squared. So that would be 7.5 newtons. In letter B, the question is if the force was now applied to B, meaning the force is now on the other side. So what if the force was here? This is in letter B. If force is 10 newtons, how much force is B exerting on A? So that would now be FBA, and that is equal to the mass of object A times its acceleration. So even if the force is now here, no, in B, the acceleration would still be the same because the total masses is still the same. It's just in the opposite direction. So mass of A is 1 kilogram and the acceleration is 2.5 meters per second squared. So the acceleration, the force exerted by B on A is 2.5 newtons. So if you notice, they add up to 10 newtons. Okay. And then there are many cases in solving problems involving Newton's laws of motion. Most of the time we'll be dealing with weight. So it's important for us to remember that weight is a force. The force with which the Earth attracts on the object is called its weight. And even if weight and mass are different, sometimes we confuse the two, but remember that weight and mass are different. They are closely related. So the weight of any object is the force that gives it the acceleration of gravity g when it is dropped. If an object's mass is m, then the magnitude of the downward force on it is, so instead of w, so that we are not confused with this one, we don't confuse it with work. So let us, instead of w, let us use, for convention, let's use F because weight is a force with a subscript W. Okay? So for subscript W refers to the weight of the object. So still, diba, we are able to find the weight of the object using the second law of motion because weight gives the object, is the force that gives any object the acceleration due to gravity. So mass times acceleration due to gravity. So, for example, problem involving weight. A loaded elevator whose total mass is 800 kilograms is suspended by a cable whose maximum permissible tension is 20,000 newtons. What is the greatest upward acceleration possible for the elevator under these circumstances? And what's the maximum possible downward acceleration? So, this case involves tension. But remember, in working out problems that concern the second law of motion or any of the laws of motion, it's usually best to begin by sketching the forces that act on the object involved, which is called the free body diagram. So your drawing doesn't have to be perfect. If the problem involves a horse, you don't have to draw the horse perfectly. You can just draw boxes or dots and arrows, of course, to represent the force. So in the problem, we are dealing with the cable of the elevator. Okay, it's suspended by a cable. So problems involving cables involve tension. So there is always tension. So the tension T in a cable or a string is the magnitude of the force any part of the cable exerts on the adjoining part. So when we draw, okay, let's say for example, this is the elevator. And then there is a string here. That's the cable rather. And then a problem says that the total mass of a loaded elevator is 800 kilograms, which includes, of course, the passenger and the mass of the cable itself. So M is equal to 800 kilograms. The maximum permissible tension is 20,000 newtons. Okay, where is the tension found in our drawing? So, of course, it will go up, no? The elevator will go up. The cable is here. This is what will pull the elevator upward. So this is a cable here. The adjoining part is this portion here, which means that there are two forces acting on the elevator. The first force is the force directed downward, which refers to the weight of the elevator. And the second force is the force directed upward, that is the tension of the cable, which causes the acceleration of a cable. So what is the maximum upward acceleration? So to be able to find the acceleration upward, diba, there must be a net force. So F net. The acceleration, this net force will cause the upward acceleration of the cable. But what is this net force equal to? This net force is equal to, that's equal to the tension minus the weight of the elevator. So I hope that you understand that. Because the elevator will move upward, then we know that the tension is greater than the weight of the elevator. So what is tension equal to? Tension is equal to 20,000 newtons. What is the weight of the elevator equal to? The elevator's weight is equal to the mass of the elevator, that's 800 kilograms, times the acceleration due to gravity, that's 9.81 meters per second squared. So therefore, the net force is equal to, okay, I hope that you are computing there, 20,000 minus 800 times 9.81 is equal to, you have the answer, that is 12,152, okay, newtons. So after finding the net force, then we can solve for the upward acceleration. Acceleration is equal to the net force divided by the mass. Okay, so the net force is 12,152 newtons divided by the mass of 800 kilograms. So the maximum upward acceleration is equal to, Okay, that's 15.19 meters per second squared. The maximum upward acceleration of the elevator is 15.19 meters per second squared.